Hi everyone, Ali here from Learn Awesome. This is a probably better remake of earlier attempt of this really important performance optimization technique where many viewers complained that it was recorded at high resolution and was therefore hard to follow, especially for coding part on mobile and tablets. On top of that, I was lecturing non-stop. Web pages should be designed for all resolutions and screen types. A good web developer never ignores this. He ensures this, he ensures that. All of that in a video that was practically not viewable on mobiles. How ironic. In my defense, you must think using a bucket theory, and I assigned videos to a different category to web. But no one would care, and I guess I am out of the good web developers list. So let me be the bad example of how you need to redesign and redo your efforts if you ignore the simple rules of the web. Anyways, welcome to yet another practice session of using HTML placeholders to improve performance, a very important technique. We discussed benefit of placeholders in the concept video, so if you haven't watched it yet, please do it first and link should be appearing on top right corner just about now. Since the video is a bit long, let me introduce you to the agenda so you understand what's going on. So before actually trying out the placeholder images technique, we'll first establish a baseline to quantify and measure the performance. We'll do that by creating a web page with multiple big images first. This would be followed by a very detailed introduction to Chrome Developer Tools Network tab. Chrome Developer Tools and especially its Network tab is an awesome resource for web developers which provides detailed timeline for network activity of a web page. We'll use it to simulate a slow network connection over which our web pages would download, and we shall measure and store timing information for comparisons. Next, we would be creating some render blocking resources and measuring impact of images on their download speed. Then we'll go over what an ideal placeholder image is, what are its qualities, followed by creating and using a low res, low size variant as placeholder and measuring the impact. Finally, we would be sourcing a single SVG placeholder and compare it with rest of the techniques. In the end, we'll finally be using placeholders using JavaScript in our web page and measuring its impact against baseline. The video would feature YouTube chapters. If at any time you feel like jumping ahead to another section, you can do so using the progress bar or the detailed timing information provided in the description with links. Right, let's switch to Visual Studio Code and get started. Okay, I've created a new folder on my machine with an images subfolder containing a single large image called face.png. This is a image I drew in an earlier video and I'm reusing it in this one. So you can use any lying around on your machine or you can create an image using Paint or any other image editing software on your machine and place it just like this one. The first phase of setup for this project involves creating 20 copies of this image. So for that, I'll head over to Explorer. For that, I'll be creating a new folder called Face Copies. Paste it there and then copy paste it 20 times. Right, next part, we need to use this. In fact, let me move this face copies in the images folder. This belongs inside. All right, back in Visual Studio Code, we are going to use this in a web page now, we are not now gonna create. So for that, I'm going to create a source folder, and inside I'll be creating a file called placeholder.html, which would be our main web page. So in previous videos, we have created web pages from scratch, but there's a neat little trick in Visual Studio Code that if you start typing HTML, it presents you with this menu where if you select the second option, HTML:5, and select enter, boom, a new web page is created for you. A very basic one indeed, but nonetheless with some markup. So we can say, right, right, next in the body section, I'm gonna be using those 20 images that I created. So for that, I'll be creating an image tag. and providing a source to dot dot slash images. Dot dot slash because we are in the source folder and we need to step one folder up to go to images folder. Then we go to face copies and select face copy 1.png. And for this demonstration, I'm going to be restricting the width to 200 pixels. Right. Next, I'm going to be repeating this line for each image. Note that there are several Visual Studio Code extensions that can do this sort of auto increment. And if you use ChatGPT or other AI tools like that, there is a ChatGPT template prompt pattern that can also help. For now, I'll be doing this manually, but for your information, I have created a video on ChatGPT template pattern as part of my prompt engineering playlist, and you're welcome to see that. The link should be appearing on the top right corner. So I'm going to fast forward from here, and you can follow along on your machine doing the poll. All right, we are done. Let's see how it looks in the live preview. Oh, it looks great. In case you're not familiar with, we are using the live preview extension from Microsoft for Visual Studio Code here. And if you don't have it installed, please do so because we'll be needing this URL that it serves the page on. So it runs a local dev server, which we would be using in our Chrome developer tools to simulate the slow network. So that would be required. If you're not familiar, please refer to a Visual Studio Code setup video in the playlist. Right. Let's go back and let's watch it in Visual Studio Code in Chrome. Right. Looks great. Let's replace this file-based URL with this one so that we can simulate the slow network connection. And I'm going to open right-click inspect, which opens Google Developer Tools. I'm going to head to Network tab. And here we are going to use the slow to crawl profile that we created in a previous video. And the way to do it is we go to network throttling profiles and add a custom profile. So I have slow to crawl profile, which simulates a 256 kilobit per second connection. So you can add your own if you don't have it already. All right. So now that we have it set up and selected, I'm going to reload the page and let the timings come up. Right, since Chrome tends to jumble up these file names, so let me sort them by waterfall by clicking on this column, and let's examine the results. So you will notice that the placeholder.html and this VS Code live preview injected script are the first two files to be downloaded. And the reason being, they are the starting points and the images are downloaded next. So HTML and scripts are given a higher priority than the images. So network activity for each image is given in the waterfall column. So if you notice there, the first two have a very small white and gray bars, but the next of rest of the images have big bars. So if we hover over any of them, a panel pops up, which basically tells you everything that went around in downloading this image, right from start to request for the image to be fully downloaded. So the white and gray portions of these bars represent queuing and stalled states. So what are queuing and stalled states? So whenever a network request is initiated by the browser for any resource in the HTML document, depending on the current ongoing activity, the request can either start immediately or it can get queued or stalled to be processed later. So there's an explanation link given on this panel. If I click this, we can have a look. The browser queues requests before connection start and when there are higher priority requests. So if there are higher priority requests going on, the resource may be queued or stalled. There are already 6 TCP connections open for this origin, which is the limit, applies to HTTP 1 and 1.1 only. So at the time of making this video, HTTP 1 and 1.1 are the de facto versions used all across the internet, and you would see them in 90% plus of the websites. And they only allow 6 simultaneous network requests to be processed. You can consider them that your browser has only 6 telephone lines available to dial your server. And if there are already 6 network requests in processing, any other request would need to wait. So they would be queued, or they can be called stalled. Or the browser is briefly allocating space in the disk cache. This is a minor thing usually and is not generally something that worries us too much. In my research for this video, I found that queuing and stalled are intermingled by the browser because the time markers used to differentiate queuing and stalled do not let browser differentiate explicitly between these two. So these two terms are usually used interchangeably. So just keep in mind this 6 TCP connection thing, and let's look at the graph again. So notice that these two non-image documents were started early, followed by these two started later. So you would see these 2 plus 4 pattern repeating over and over again because the two things started early. And then the other images are being downloaded. So this batches of 6 are going to be repeated over and over. If there were more images, you would see the same pattern repeating again and again. In addition, if we look at these requests, you can consider them to be composed, each network request to be composed of 4 parts. One is a pre-request, the other is request processing on the server, third is TTFB or awaiting response from server, and then content download. So pre-request portion is represented by these queuing and stalled state along with this DNS lookup, which essentially means if you have a URL for which the IP address is not yet determined, the DNS lookup would be the time spent in doing so. This is external to browser and server, so it is listed separately. Then this request sent essentially means the request is sent to the server, and the server is now processing the request and preparing a response. Waiting for server response, also sometimes known as TTFB or time to first byte from server, is the third one where the server hasn't responded yet. So this is the server time where browser has no option but to wait. And then the content download is where content is downloaded from the server to the browser. So we'll stick to only things that are relevant to images and placeholders at the moment, and we'll probably make another video on network on the Chrome developer tools later on. Please note that images are downloaded at lower priority than scripts. So there's a priority column right here where you can see the HTML was given the highest priority and images were downloaded at high priority. So the things that take priority over images are HTML, script, fonts, and style sheets. All of these are called render blocking resources. That is, they won't let anything appear on screen before being downloaded. So browser has no choice but to give them the utmost priority because otherwise user would be staring at a blank screen until all of them are downloaded, and images can be downloaded later. So any other thing would be put in the queue and would be downloaded later on. So for images, the most important things are these two because the others have those queued and waiting times added. So we know that every image is taking around 5 seconds using our slow to crawl network profile. Right, let's go back to Visual Studio Code and continue with our test. Okay, next up we are going to be adding a render blocking resource to our web page, a big one, and we'll note how much and how it impacts the web page download and how the images existing in the web page affect the render blocking resource in return. It will make sense in a second. So let me close these and make the change. So to do that, I'm going to add another folder called styles. And in here, I'm going to be adding a loaded sheet.css. In here, I'm just going to be adding a very simple style, background color, aqua. To make it big, I'm going to be adding a comment. I'll be sourcing the content of this comment through a website called lipsum.com, where we can generate a large piece of garbage text and copy and paste it in our. And so I have chosen a 500 paragraph garbage text, which essentially means 150 paragraph, 13,000 words, and 91,000 bytes. Here we go. Our web page should be bloated now. And note that this is a comment, so it won't affect the CSS or page in any way, but it would definitely impact the download time of the render blocking resource, which is the style sheet. So let's add the style sheet to our head section. Link rel equal to style sheet and href equal to styles bloated sheet.css. Here we go. Let's go back to Chrome, clear the network page, and reload. Notice here, nothing is appearing because of the render blocking resource, because it's not fully downloaded yet. See, still going. All right. So as soon as it finished, you saw things filled up quickly. The images are still downloading, but note here, for 16 seconds, there was nothing on the screen. In fact, this is an important point, so let's do it again. Where's the style sheet? Here it is. 12, 13, 14, 15. It should be appearing just about now. Yes, it did. Let the images fully download and let's examine. So I'm going to sort on waterfall because otherwise the local dev server is so fast, these timings get jumbled up. Right. So let's see. So the browser, as expected, gave highest priority to HTML, script, and the CSS file. And the CSS file blocked everything from appearing for an entire 16 seconds, which is huge. And the file size is 92.2 KB. So now that we know how render blocking resources impact the website or web page, let's go back and see how much of that download time or staring at a blank page time is being impacted due to the images. So to do that, so what I'm going to do here is to simulate that effect is I'm going to comment out all the images. So now the web page has no content almost. This is an insignificant size. So the entire web page is now going to be dependent on this style sheet alone. So let's go back to Chrome and reload and see how much time it takes. 3.56 seconds for the CSS to download, which was taking 16 seconds to download. So if you think there's something wrong here, let me add a hello comment here, come back, reload, and see the hello appeared right on time. So how did removing images brought the time from 16 seconds to 3.57 seconds, which is a almost 400% improvement. So the reason being that while the CSS is being downloaded, the images are also being downloaded in parallel. So your network traffic can choke. So even though the CSS is being downloaded at the highest priority, the network traffic is being choked because of multiple downloads being done simultaneously, and it affects the render blocking resources, and you can see to the tune of 400%. And the reason being that we are using full-sized images in our web page. So in practical use, both of these are gonna impact each other. So to understand what I mean, now let's go back and uncomment the images and now have a close look at this. So CSS is being downloaded at highest priority, but note The images are being downloaded, but are not being shown until CSS is fully downloaded. So the images being downloaded are slowing down the render blocking resource download, and the render blocking resource is not letting you see the images that are downloaded and available to be shown. So it's a lose-lose situation which we are now going to address using placeholder images. You must note that industry recommended time for first colorful paint or first render, or time it takes from the user pressing go to seeing the first dot on screen appear, is 1 to 2 seconds. And for a variety of reasons like download of huge CSS files like Bootstrap, font libraries like Google Fonts, and scripting frameworks like React or Angular are common practice. So 1 to 2 seconds is a big ask on a commercial website requiring all your skills to accomplish. You can't waste it away making render blocking resources downloading even slower by suboptimal use of images. So it's finally time to introduce placeholder images. To recap, an ideal placeholder image must be small in size, must be scalable, and size of file depends on a lot of factors. Compression plays a big role when JPEG, PNG, etc. are much smaller compared to uncompressed BMP files. Then intrinsic file size matters, where if you reduce dimensions of image by using any resize tools in various editors, the file size is reduced drastically. Color depth is another important consideration where grayscale images can have color represented by one 8-bit channel compared to typical 3-channel color image. But that also depends on how you save the file and whatnot. This is a topic of its own, but typically using grayscale helps reduce file size. The best of both worlds, that is, file size and scalability, is of course SVG format, which is not a picture in first place, but it's essentially a piece of code. So ideally, it's always the best choice for a placeholder, unless you are trying to use a low resolution version of the same image to use as a placeholder, you would use an SVG. Now it's possible to save a JPEG as SVG, but be careful, it can be larger than the JPEG itself. And honestly, I haven't tried it, but as far as I know, SVG is scalable vector graphic, and you can't have a better performance with a raster image being saved as an SVG format, at least not for use in a web page. So there are two most common ways to use placeholders, and first one we are going to look at is to use low-res version of original images on web page, which is a popular technique. So let me show you quickly how to do that. So let's open face.png file in Microsoft Paint. Alright, as you can see, it's a 1294 by 996 pixels files of 32.3 KB size. Right? We are going to resize it using the resize option in Microsoft Paint, which I'm using as my editor. So I'm going to give 10 as the value and press enter. Right, it's now a 129 by 99 pixel file, and I think the size appearing is old, so let me save it. Let's save it as face thumb.png. Press enter. And see, it's now a 9.1 KB file, so it's almost a third in size than the original file size. Right, now we are going to use these images, copies of this face thumb image in our web page and see how it responds. So to do that, I'm going to go back to Visual Studio Code, but before that, we need to make face thumb copies. So I'm going to fast forward again, and you can do the same on your side. Okay, back in Visual Studio Code, what I'm going to do is I'm going to replace face copy with face thumb copies slash face thumb. And hopefully we'll not need to do anything else. Okay, let's see how it looks. Perfect. Looks good, right? Since we are using the 200 pixels, you can't really tell the loss of details, but say if I blow it to 800 pixels, Then let's see how it looks. So I'm gonna say width, replace width 200 pixels with width 800 pixels. And yeah, now the loss of detail is really apparent. But the advantage is good. So you can reduce it even further until user can barely tolerate the image, and that would be your ideal boundary. A tolerate a, a barely tolerable version, a barely tolerable version of real image until you can replace it with the actual here. We can clearly see that we have room to go even further, but I won't at the moment. Right, why not we head over to Visual Studio, to Google Chrome and see what the results look like. All right, let's open the Chrome Developer Tools and head to Network tab, clear everything, and reload. Here's the CSS. Here it is. Yes, so the CSS got downloaded in 9.79 seconds, which is still considerably higher, but much better than 16 point something seconds for the with the original images. And as you can see, we have a lot of room to go even further with these blurry images. In fact, why not? All right, now I'm just compelled to do another test, so I'm gonna fast forward the entire test um, and we'll see the results. So right, so this time I'm going to resize it to 50% of its reduced form. So from 129 by 99 pixels, it would be reduced to 64 by 49 pixels. And I'm gonna save it as micro thumb. Okay, I'm gonna make 20 copies now, so all in fast forward. Okay, we have made our changes. Let's look at the preview. And yes, they are a lot more blurred than previously, but still might work as placeholder images, right? They are just placeholders and user can tolerate them until we replace them with the other one. Let's see what the impact is. So I go back to Chrome browser and remember we have to use this 127001 address to enable network throttling. So let's reload and see the impact. All right, so the bloated sheet.css got downloaded in 6.24 seconds, down from 9.85 seconds. So a decent improvement, I would say, given that it is still a tolerable web page. Okay, enough with the low resolution, low size placeholder images. Now let's move to the second category of placeholder images, which is the SVG. And for the SVG, I would tell you about a good website where I source SVG images from. This is not a sponsor video or something, but I like that website. And the website is called placeholder.co. Let me bring it up. So what it allows you to do is there are a bunch of options. You can download a placeholder image which is of SVG format, depending on size, format, color, text, etc. So what I'm going to do is I'm going to use this text one, which if we copy and paste in the URL, you can customize it all from here. So since this is an SVG image, I think a 660 by 40 image would be more than enough since it's very scalable without any loss of details. So that should be good. So I'm gonna download this one. All right, I'm gonna call it 6040 SVG placeholder underscore 60 by 40. Okay, let's go back to Visual Studio Code and use it. So I'm gonna do something different here this time. So I'm gonna replace this source equal to using the replace tool with data dash source equal to. Right, what does this do? So every element in HTML has a data dash static attribute present on them, which allows you to save custom data, like any data of your choice in an attribute. So the attribute must be prefixed with data dash, but the static part can be anything. So you can call it data dash Ali, data dash learn awesome, uh, anything really. So we are calling it data source, and it's just saving a custom value in the data dash source column attribute. So how is it useful? Why am I doing this? We'll see it just in a while when we start using this scripting to actually replace the placeholder images with actual images going forward. But for now, what I'm going to do is I'm going to introduce source equal to back, and this time with the placeholder with the SVG image. So here it is, SVG placeholder, and I'm gonna do it for all image tags. Image, here we go. Replace all, and we have the image. All right, we are using the same SVG image placeholder for all of these images, so they are all gonna look the same. All right, while data source is different for all of them. Let's check in the preview. Yeah, looks good. All right, let's go to Google Chrome and see the impact. So let me clear everything and press reload. And we are done. But how was the web page available the entire time? Sometimes this Chrome doesn't clear the page up front. So let me show you how it happened by first going to the offline mode, saying, and now bringing the slow to crawl back and reloading. So yes, so the web page appeared after the CSS got downloaded, but how much time it took for CSS to download? 3.67 seconds. Awesome, right? It took the same amount of time as it did without any images in the web page. Really amazing. And why? Because the SVG placeholder is just 2.6 kilobyte, took half a second to download, and has been reused across the entire web page. See, there is just one entry, one network request for this file, not 20 or 30. So the benefits of using SVG are enormous. And as you can see, we downloaded a really low res placeholder image, but still there's not the slightest loss of detail. In fact, if I uh, zoom in, or let's go back and make it even bigger. Let's say I make the first one 2000 pixel, right? And go back, and here's the 2000 pixel image. If I can bring some of the text in the picture, you see there's not the slightest of blurriness or anything. There are still sharp, crisp edges and everything. So SVG is the best placeholder and should always be prioritized over anything else. And as you can see, if I click on the file itself, here's a preview of what this SVG image is. So this is the entire image. As you can see, it's just a small piece of code which is scalable. Let's go back to Visual Studio Code, and it's finally time. You should get ready to uh, write a script to replace the placeholder image with the actual image once it gets available. Right, we are back in Visual Studio Code, and I'm sure you're excited to write some JavaScript. But before we go there, we need to fix something. So this data source was supposed to be pointing to the actual real high-res image, but currently it's not. It's pointing to the face micro thumb. So let's fix that. So I'm gonna do some Control H and bring in the replace dialog, and here we need to replace it with face copies slash face copy and do a replace all. And now I think it's fixed. Okay, so just to make sure you understand what's going on here, we have these image elements where source is pointing to a placeholder image and data source is pointing to the actual real high-res image that it is supposed to point to. And what our JavaScript code is going to do is it's going to try and replace the placeholder image with the actual image once it's downloaded and available. And the trick is that we are going to wait until the web page has fully downloaded with placeholder images. And once all the placeholders are in place, the web page is displayed, everything is neat and clean, then we are going to start initiating download request for the real images. And once they are available, we are going to do the swap. That way, they would not interfere with any ongoing download or something like render blocking resource, etc. Hopefully, that should be much faster. How do we know when the page has finished downloading all its contents and has been displayed? So we are going to use something called event. And the event that we would use is the window object's onload event. Window is the top level object in DOM. You'll see in just a second. For now, you just need to know that it indicates that web page has downloaded all its content. Rather than going into theory, let's start writing our first script. So in the head section, we are going to start writing a script section. So I'm going to write a script. There is a type attribute on the script element where we can specify the language or the type of script that we are about to write. But if we leave it empty, this indicates that we are writing a classic script containing JavaScript code. So if JavaScript is something that we intend to use, the recommendation is to skip the type attribute. Next, we declare a handler function, which is essentially a piece of code that would be called in response to the Windows onload event. So let me just declare the structure of the function and then we shall fill out with image replacement code later. So a function or reusable piece of code is defined using function keyword followed by name of the function, which is the name we shall use to identify it. It tells JavaScript that a reusable piece of code exists that can be called by using the name, like in our case, replace placeholders. Calling the function would execute the function code, and then comes the argument list, which is enclosed in brackets. And since we are not using any arguments here, we can just give an opening and closing bracket, and we are done. Arguments, for your information, are named placeholders for any data we intend to pass to the function, and function code could use that, so we can ignore it for now since we are not passing anything. Then comes the actual body of the function where its code lives in, and it's separated from the word by using these curly braces. Right, before we write that code outside the function and in the script tag, we now tell HTML to notify us when document of web page is finished loading using the onload event, like this. So window.onload equal to replace placeholders. Right, so when the web page is finished downloading, the browser is gonna invoke onload event. And since we have assigned this replace placeholders function to this window.onload event, it's going to be called, or its body is going to be called. So let's start writing some code. Once the web page has finished downloading, we'll evaluate all elements one by one. So the first thing to do is we need to get a list of image elements that exist in this web page. And to do that, we declare a variable, which is a holder for our results. You're going to just see in a second. So I'm going to call it image list. So our list of image would be fetched by using the DOM's document object, and it has a function called get element by, get elements by tag name. And in here, you can specify any tag name, anchor element, image element, button element, input elements, forms, etc. So here, since we are only interested in image elements, I'm going to just type the star tag, the tag of the image element, img, and it's going to return me any image element that exists in this web page. Perfect. Now, since this image list is a list of elements, image elements, we are gonna iterate over it. By iterating, I mean we are gonna go over this list one element or one entry at a time. So to do this, the syntax is using a for loop, that for let I equal to 0. So I is going to be our indexing variable, which would tell which image element in the list we are trying to work with. And next would be I is less than image list dot length, which means this I variable would be would go from the first or zeroth element in the image list to the final element. And then we say I plus plus, which essentially means increment I one by one. In combination, this entire line means go over each entry in the image list one by one. Now inside this for loop, and this is the body of the for loop in the curly braces. So now we are going to say current image in loop equal to image list of I. So this is a way of telling this is a way of telling JavaScript that please return me the ith image in the list, where I is a number from 0 to the length of the image list, and assign that image to the image element to the this variable, current image in loop. Now next is where things start to get interesting. So I'm going to declare another variable which is called new image, or we can say temp image. Temp image equal to new image. Now image is a type, and new image means that we are declaring or creating an in-memory temporary image in memory, right? What are we going to do? Just bear with me 1 second and you'll find out. So next, we're going to set some piece of code to the onload event of the temporary image. Right? What does it mean? So just like we did on this window.onload, which basically meant that whenever window.onload event occurs, call this code. So we are going to do the same with this temp image onload code. So temp image.onload equal to, and now we are going to assign it a function that is going to be called when that event occurs. And in that, I'm going to say current image in loop dot source equal to this dot source. All right, just bear with me 1 second. I'll come to it after the next line. So here I do temp image dot source equal to current image in loop dot dataset dot source. All right, so do you remember we did this data dash static attribute assignment in the image elements? So those data dash static attributes are accessed in JavaScript using dataset object, right? And after that data set, we just provide the value that we assigned after data dash, right? This is the syntax. So what this line is doing, it is fetching the value of this data source attribute using this syntax and assigning this value to temp image.source, which is our in-memory
transient image. Here's the interesting part. As soon as we assign a source value to this temporary image, a download is going to be triggered. A network request is going to be initiated for the value that we just assigned for this hyperlink, right? And this essentially means that once, let's say we are evaluating this element, so once we do execute this line, a network request is going to be sent for this face copy 1.png, which is the actual big high-res PNG file, right? And once that image is finished downloading, so just like when the web page was finished downloading, the window.onload was invoked. So when the image is going to be downloaded, our big image, this temp image.onload function is going to be downloaded. And what are we doing inside the body of this function? We are swapping this source attribute value with the actual real image value. Once this temporary image has downloaded the high-res image and it is available in memory, then we are going to assign the current image in loop, which is, let's say, this one for the first entry, and that source is going to be containing this value now. So data source and data dash source and source are going to have the same value. And what is it's going to do once this line has executed, the browser is going to make the change appear in the browser window. So this high resolution image is gonna replace the value that was previously assigned to this source. So what I mean by all of this is that the placeholder image is going to be replaced by the real image once it's downloaded and available in memory. All right, so would this work? Let's see, only one way to find out. So I'm gonna press Control Save. Let's just go to directly to the Chrome browser and see the result. Okay, let's read out the page. The placeholders have arrived. 6 images seem to be downloading. And yes, 6 placeholders have been replaced, and you'll notice it's gonna replace all of these in batches of 6. So here we go. Yeah, see? And let's look at the results. So the CSS got downloaded in 3.61 seconds because it got downloaded along with this SVG. So the entire scheme of things remained the same until here when we tested the SVG placeholders. And after that, our our JavaScript code got invoked and it started downloading all these images, 6 in a row. You see, all these 6 are now being downloaded in one batch because it's not being affected by high priority requests. Each image took 6.55 seconds. Our script is working. It is replacing all the placeholders 6 in a row with the actual images. And things look great. One more thing that we can try, we tried with this SVG implementation. So I'm going to just take a second and try the blurred image or low res image implementation as well, because that is also very practical and sometimes usable. So let's go back to Visual Studio Code and right, we are done. Pressing save, going back to Chrome. Right, let's clear the network log. Pick offline, refresh, slow to crawl, disable, refresh. Okay, this time you can see the thumbnails are downloading first and they have rendered, and now the actual images have started to download, and the blurry images are being replaced with the actual ones 6 at a time. And we are done. Let's look at the numbers. The CSS got downloaded in 4.92 seconds compared to the 3.6 seconds or something with the SVG placeholder image. And the reason being, we are not downloading one SVG image to act as placeholder for all images. We are downloading individual PNG files, which are 4 kilobyte in size, so double than that of the SVG, as well as there are 20 of them. So some effect on the CSS file download. So it took a complete second or more to download on the render blocking resource. And afterwards, all of the images quickly replace them. So I think in practicality, strictly adhering to the numbers, the SVG wins. With blurry images, the experience is a bit better, but at cost of one or more additional second. Is it good or bad, right or wrong? I can't say. The only judge in this story is the user or visitor. If he likes blurry images for a trade-off of a few additional seconds, nothing like it. But in the field, one should never assume. If you are confused, please do surveys, get feedback of some of your users, and then decide.
So I was noting down some numbers for all the experiments that we did and have compiled them in this Excel sheet. You can see how render blocking resource download time shifted from experiment to experiment. Such statistics are invaluable to make a better judgment and get better insight into how things are related to each other. Column C and D are image download time and size for all experiments, just for reference. E and F are ones I added to show how placeholder techniques gives user a perception of super fast web page, and you can see that with SVG and micro image placeholders, the user has a total or entire web page rendered with low-res images in 3.97 and 6.86 seconds respectively. Note that these are durations after which the onload event is invoked and our script begins execution and starts to download the high-res images, and finally the web page with high-res images is ready in 24.9 and 27.7 seconds with real images. All of these stats include the bloated render blocking resource, that is the CSS as well, from column B. Goes without saying that the benefit of placeholder strategy is more than obvious. Please pause and compare rest of the statistics too, just for understanding purpose, and best to make a habit of quantifying things like this, as it always leads to better decision making. This brings us to the end of this somewhat lengthy video. I hope you found it useful and you'll be able to apply this knowledge in your career. Please give a thumbs up if you found this informative and consider subscribing to the channel. Thank you. Goodbye.